Right, the first part of circle is just getting used to the two different parts, two different equations. But obviously there's a lot more problem solving involved in circles than just dealing with the equations, okay? One of the main ones is dealing with tangency. So there's two aspects to this, okay? It's the first one is just finding actually the equation of a tangent. The second one is determining whether a line is a tangent or not. And that's a little bit more tricky. Okay, but I've looked at a lot of past paper questions in terms of circles, and they have a whole variety of forms. So this is definitely one that you want to practice as many types of questions as you possibly can. Okay, but we'll start with this nonetheless. Okay, so we know what tangent is already. We've seen a tangent. It's a line that makes contact with a circle at only one point. Okay, and it's important that it's only one point. If we were to find the equation of a tangent at a given point, we must first find the gradient. Okay, at the end of the day, a tangent is just a straight line. If we're going to find the equation of that straight line, it's the same things we always need. We need a gradient and we need a point. Okay, most of these questions are given by the fact that you have a point like this one. You just don't know anything about the gradient. Okay, so that's where what we did in National 5 kind of comes in. Okay, so you know from a circle and a tangent from when we did National 5 that the point at which a tangent meets a circle, if we were to draw a line from that point to the center, that line would be right angles to the tangent, okay? So we did perpendicular bisectors initially in National 5, okay? I would have called it that, but we just don't spend too much time dwelling on the name of it. Obviously, you do a bit more in straight lines now, but when we're dealing with circles, a tangent and a radius will meet at right angles, and that's the main thing you need to know. So as long as we've got an equation of a circle, obviously we can get a radius, okay, but that's not going to help us here because it's a length, but we can get the center, and if we can get the center along with the point of tangency, okay, then we can basically get the gradient of the radius, and if we get the gradient of the radius, then we can get the gradient of the tangent by flipping it upside down and times it by -1, okay? So in terms of a diagram, this is the kind of thing that we'll have. Obviously, because of the equation that we've got, we'll know the center. Because we've got a tangent, we'll know the point at which they meet, in which case we can think of a line. We don't need to draw it. We don't need to actually represent this in any way. But the point is that dotted line there will be at right angles to the tangent. And if we can find the gradient of that dotted line, then we can simultaneously find the gradient of the tangent, okay? So that's the kind of situation we're dealing with here. So the first thing we want to do is find the center of this circle. So same as always, 2g is going to equal the -4. G is equal to -2, 2f equals -2, f equals -1, in which case the center is 2, 1, okay? So that's the aspect that we've done so far. That's all we need. We don't need to go on and find the radius because it's just a length. It's not going to help us in terms of equations. But the idea is we can combine that center with the point of tangency and we can find a gradient of that line. But just be careful. As I say, this isn't going to give us the gradient of the tangent. This is going to give us a gradient of a line perpendicular to it, okay? So substituting those points in, we get 1 minus 3 over 2 minus 4, which is -2 over -2, which is just 1. But going by the formula, you don't need to write this out. You can literally just write m perp. Okay, the perpendicular gradient is 1 flipped upside down, which is still just 1, times by -1, which will give us -1, okay? So that's the gradient that we need to go forward with to find the equation of the tangent. We've already got the point, so it's just a case of using y minus b equals mx minus a, along with the point and the gradient -1, and just working it through to find out the equation of the line, y equals -x plus 7. Okay, so that's the first kind of aspect of tangency that we look at. The second one we look at is basically where it actually intersects. So we're trying to determine, and this is quite a common question, determine whether a line is a tangent or not. Okay, so in general, there are 3 options when it comes to lines intersecting circles. Okay, see if you recognize this and where it's going. So we're either going to have this situation where we're going to have 2 points of contact. Okay, we're either going to have this situation where we just have 1 point of contact. In other words, we have a tangent. Or final option is that we have no points of contact. So hopefully this kind of rings bells in your head where we've used something like this before. Okay, we use this obviously when we're determining the nature of the roots of an equation. And in the same way, we can basically use that method here, okay? So we would be trying to prove whether or which of any of the previous 3 occur in any given situation. So the question will just be determine whether the line, how many times the line intersects the circle or something along those lines, okay? So we have different options to find this, and this is part of the issue with with circles, is that there's lots of different ways of doing the different questions, okay? And this is where you need kind of a lot of different strings to your bow, in which case you can use all the different methods and you can find the most appropriate one for you. One might be simpler than the other, okay? But it helps to know all the different ones and then go from there. So if we're going to find the exact point at which they intersect, we can do substitution. At the end of the day, we're trying to solve these equations, and if we take one equation and substitute into the other, okay, similar to what I showed you before, we hopefully get rid of all the variables apart from one, and then we can solve it to find that one variable, and it will help us get the point. Obviously, a point is made up of 2 points, 2 values, so we'd have to go one step further. We could use elimination, in other words, simultaneous equations, but it's a bit more awkward when we've got an equation of a circle, okay? The final one is to make the equations equal to each other, but again, that's quite awkward, given that a circle equation involves x's and y's and x squared and y squared. If we were to try and siphon off one of them, it makes it a little bit more awkward. It's not impossible, but it makes it a little bit more awkward. Okay, so the first one is probably our optimal choice there. Right, if a curve cuts the x-axis, we have one main option to prove how many times this occurs. So this is what I was touching on before. So we can use the discriminant to find how many points a curve touches the x-axis. And we can do the same thing with a line and a circle, okay? So if you're just asked to determine how many times it touches, then you can use this one. But if you're asked, and this is important, if you're asked to determine exactly where it touches, then you probably want to go down the line of substitution, okay? So I'll show you this in this next question. So we're going to show that the line x plus 3y minus 11 equals 0 is a tangent to the circle x squared plus y squared plus 2x plus 12y minus 53 equal to 0, and find the point of contact. Right, the issue here is that we could make these both equal to each other, but that's not really going to help because we're still going to have lots of x's and y's. Ideally, what we want to do is get rid of one of the x or the y. So if we rearrange the equation of the straight line and then substitute it in, then we can substitute it for a y or an x and get rid of it. Right, there's a slight difference here. So you might be tempted to do this in one of two ways. You might be tempted to rearrange this for y, because ordinarily that's what we do. But if you look carefully at this one, if we rearranged it for y, we'd have to divide through by 3, in which case we'd end up with some weird and awkward fractions. So by rearranging this for x, there's nothing wrong with doing that. Then we make our what we're going to substitute in slightly easier. So this is where you want to think ahead and try and work out what you want to do. Okay, so we're going to rearrange, first of all, we're going to rearrange this equation for x, and it's just going to be 11 minus 3y, which is easier to work with than what the y would be, which would be 11 minus x over 3. That's not very nice. Okay, and we're going to pop that in place of all of our x's in the circle equation. Okay, so all the x's come out, so the x comes out here, and we replace it with 11 minus 3y. We still square it, we've still got the y squared, and then we're going to do 2 x's, so 2 of our 11 minus 3y's, add on 12 y's, take away 53, equal to 0. And now we've got a new equation, and this equation is going to tell us where these two lines, the line and the circle, meet, and we can solve it because we've only got one variable. It's not a very nice one. Okay, there's a lot going on here, but we've just got to take our time and consider all the little things. Right, first thing I want you to think about is the fact that this is squared, and we can't just write 121 plus 9y squared. It's FOIL, so we have to multiply it out properly, okay? So 11, and you might want to write this out properly. This is going to be 11 minus 3y times by 11 minus 3y. When we do that with FOIL, we get the 121, and then we get minus 33y, and then we get another minus 33y, and then we get a plus 9y squared, okay? Move on to the next bit, we've got the plus y squared. Multiply out the second bracket, you've got 22 minus 6y, and then you've still got 12y and the minus 53. Don't try and do anything with that until you simplify it. Gather all the terms together. What you'll notice generally with these questions is that they do simplify quite nicely, okay? These all divide by 10 now, okay? You might want to put it in the form that you're used to, so 10y squared, it's minus 60y, and it's plus 90. But we can divide this all through by 10 to give us a much, much easier to work with, much nicer equation. So y squared minus 6y plus 9 equals 0. Now it's just a case of solving this, okay, by factorization. So split it into 2 brackets, y minus 3 and y minus 3. Right, what this is basically saying, this is telling us where our points of contact are going to be, okay? And because it's a repeated root, that means there's only one point of contact. And therefore, x plus 3y minus 11 equals 0 is a tangent because there's only one point of contact. Right? We could have proved that. We could have gone with this version and used b squared minus 4ac and actually just gone ahead and just shown that there was only one point of contact, because b squared minus 4ac would equal 0. That would show us that there's just a tangent, okay? But because we actually want to find the point of contact, the question asks us to find the point of contact, it's almost better to actually go and find that point of contact by factorization and just prove that it's the only point of contact. Okay, so y minus 3 equals 0, in which case y equals 3. is part of the point of contact, but obviously we need to find the full point of contact. So we need to take our y, substitute into one of the equations, obviously the straight line equation is easier, and work out that x is 2, in which case the point of contact is 2, 3.